We're going to look at the idea of currying and curried functions, and also the idea of partial function application. We're going to use a simple example of an add function that simply adds integers together. So let's have a look at how this works. To begin with, we are going to first of all define our add function here. So we're going to do that, and it's going to take in two values, two integers, and it's going to return an integer. Now notice this is a tuple, so this function here is only taking a single argument in here. Even though there's two values being taken in, it's only taking a single tuple as an argument, so a single argument. Now we're going to define the function itself, so add, and it's going to take our two values, x, let's call them x and y, and then we simply add those together, so x plus y. So that now is our function all sorted. Let's now save that and let's test it out, make sure it's all good. So we're going to do add 3, 4, and it all works. Now I'm going to define a function add in a different way. I'm going to call this add2, but nevertheless it's going to do the same thing. It's going to add two integers together, and in this case we'll do integer, integer, integer here, and I will also just write the function out before I explain that function type at the top there in a moment. It's going to take x and y, so this will take two different parameters, and then x plus y. So what's happening in this case, or what's happening in the case of curried functions? This is a curried function because functions with more than one argument, and you can see this one has two arguments, take the arguments one at a time and then return a function, which is what's happening here, which if you have many different parameters, can even return functions which themselves have functions until there are no more arguments to take. So in this case, what we're doing is it's applying it to a single parameter to begin with, single argument to begin with, and then from that is then returning a function of this type that has int and then returns int. So int is a parameter and then it returns int. Let's have a look at how this works now. So if we just again save that and run this through. So we're going to do add 2, and then we've got 3 and 4 as two parameters now, two arguments, and that should work. I forgot to load that, that's why that didn't work. So if I do load demo.hs, and if I now do add 2, 3 and 4, that should work, which it does. So that's all good so far. Now what we can do, as I mentioned, we can have it so that we're only doing a partial function application on this. So let's demonstrate that now, because what we can do is let's call this partial 1, and we're going to do add 2, and we're only going to do a single application to a single parameter here. So we're going to do add 2 and then 3 here. So now we've created a new function called partial 1, and when we apply partial 1 to a value, what it will do, it'll add 3 to it. So it's essentially a function that adds 3 to a value. So partial 1, let's apply it to 4 there, and it will return us 7. So you can see the partial function application being applied just to a single argument in this situation. Just to make sure this point is clearly understood, I'm going to now use it to add 3 numbers together. So we're going to create a function that takes in 3 numbers and adds them together. So let's demonstrate how this works. So we're going to call this now add3, and what it's going to do, it's going to take an integer, take 3 integers one at a time, and in this situation what happens is, and you don't have to include brackets in this definition, but I'm just going to do it anyway just because it clarifies things. So when we take the first value, the first integer, what it will do is it will return a function, and then when it takes second value, it'll return another function, like so, in this way. As I said, you don't have to include the brackets, but it does help to clarify what's going on. So the first integer takes an integer and returns a function, and the second value takes an integer and then it returns a function. Now if we now just define the function itself, we've got x, y, z as our three values. If we do equals x plus y plus z. So let's now demonstrate this, the partial application of this. So if we go down here now, let's make sure we load that and do demo.hs. And that hasn't liked that very much. Let's have a look at the problem with that. It looks like I forgot to put the 3 there. So make sure we save that then, try that again. Load that again. That's all good now. Now if I do partial 1 equals add 3, and we're going to add 3 first. Now what's going to happen is it returns a function called partial 1 that's basically going to add 3. Then we're going to do partial 2 now, which is going to be equal to partial 1. So we're going to add 3 to the 4. So what partial 2 now will do is it'll add 7 to whatever value we put in here. So partial 2, let's run that, and then if we do partial 5, and if we run that then, hasn't liked that very much because I misspelled that. Partial 2 and then 5, and you can see there it's given us 12. So that's quite a nice demonstration of an application of partial functions.